Hi viewers, welcome to Sai Praveen channel. Today we are going to learn about the Kirchoff's Voltage Law, KVL, Voltage Law. This is the Voltage Law. So, what is this law? What is this law explained to us? The law explains to us is the energy never be created. The energy cannot be created in a circuit. The energy cannot be created in a circuit. This is the statement tells to us. And the statement, while coming to the statement of this Kirchhoff's voltage law, here it is that the law states that the sum of the voltage drops across the elements present in the circuit is equal to the sum of the applied voltage sources. Sum of the applied voltage sources are the algebraic sum of the voltage drops and the voltage sources around the circuit elements is equal to 0. Is it right? So, what is this statement explains? Let us explain this statement by using a circuit. Let us take the circuit. For example, here let us take a circuit like this. So, this circuit is connected with a voltage source plus minus Vs and the resistors are R1, R2, R3. So, these are the elements present in this circuit, particular circuit, which is connected to a voltage source Vs. Now, this voltage source makes a current I flowing through the circuit. So, I is flowing through the circuit, current I. Now, what happened? This I travels through the R1 resistance. So, what happened while the current, what is the purpose of using a resistance? It opposes the flow of current through it. So, while this process, when the current is entering into the resistance R1, the resistance opposes the current I1. Due to this opposing this particular current I, there should be some drop that is known as VD1. Here the same thing VD2. Here also the same thing happens VD3. Is it right? Due to the circuit is series circuit, so current flowing through all the elements in a series connection is same. That's why we are considering I in each and every element. Okay, current I. So, VD1 is the voltage drop across resistor R1, VD2 is the voltage drop across resistor R2, VD3 is the voltage drop across the resistor R3. Is it clear? So, VD1, VD2, VD3. Voltage drop across R1, voltage drop across R2, voltage drop across R3. Now, what is our statement? What is Vs is the applied voltage source. Vs is the applied voltage source. Voltage source. So, coming to our statement, what is our statement explained? See here, the law states that the sum of the voltage drops across the elements present in the circuit is equal to the sum of the applied voltage source. So, what are the drops here? So, VD1, VD2, VD3. VD1, VD2, VD3. These are the drops. Now, we are going to what? States that the sum of the voltage drops, sum of the voltage drops. So, we are going to add this one. VD1 plus VD2 plus VD3 is equals to VD1 plus VD2 plus VD3 is equal to sum of the applied voltage source. What is the applied voltage source here? Vs. So, that is equals to Vs. This is the equation for the KVL. Very simple. Very simple. you see here, the sum of the voltage drops. What are the voltage drops? Voltage drop is nothing but energy dissipated from the resistance R1 while the current I is flowing through it. While the current I is flowing through it, the resistor opposes the current, flow of current. It doesn't stop, it just opposes the flow of current. This opposing flow of current makes some energy loss, makes some energy is dissipated. In case of resistor, the energy is dissipated in the form of heat. So, that heat makes to drop some voltage, that is known as voltage drop. Like this, in each and every resistor, the voltage drop happens. So, the voltage drop across R1 is VD1, voltage drop across R2 is VD2, voltage drop across R3 is VD3. And coming to the statement 2, what is this statement 2 explains? The algebraic sum of the voltage drops and the voltage sources around the circuit element is equal to 0. We are going to make the algebraic voltage sources like this: VD1 plus VD2 plus VD3, like how we do the same thing in KCL, Kirchoff's current law. The algebraic sum of the currents entering into the node and the leaving from the node is equal to 0. So, we can do minus Vs. This is the statement 1, this is the statement 2 form. Okay. So, this is the all about the Kirchoff's voltage law. So, if we consider the same thing for the RLC circuit, series RLC circuit. So, while doing the series RLC circuit, by applying the loop law, Kirchoff's voltage law, what can we do? We are using the elements inductor, resistor and capacitor. Let us see. Let us see this. Now, we are doing the same thing for RLC. See here, what is the circuit? This is the EMF E, voltage source E, R, L, C, R, L, C. So, what happened? Now, the current I is flowing through it. Now, what happened when the current I is flowing through it? Here, the resistance has some voltage drop due to the flow of current I through it. So, it will become VD1 is equals to, what is that? I into R. Why? Because we are going to take the voltage drop. What is the formula for voltage in Ohm's law? IR. So, we can write like this, I into R. Next, coming to the VD2. What is the formula for voltage in inductor? So, V is equals to L into di by dt. Okay. The voltage drop across the inductor. So, you can write like this: V d1 here, V d2, and here I will write inside V d3. So, V d3 is equals to 1 by C integral V into dt. This is the coming to the capacitor. Now, we can add all these things, then what happened? According to the Kirchoff's voltage law, the sum of the voltage drops across the elements present in the circuit is equals to applied source. What is the applied voltage source here? E. Voltage source here is E. Why we are considering E? Because this E is the time varying voltage source, AC, time varying voltage source. Inductor is also time varying inductor. Resistor, both the phases are in phase, that is why for the resistor there is no dt, but coming to the inductor and capacitor, there should be a dt value. Okay. Now, if we write the equation for this, then it will become I into R plus L into di by dt plus 1 by C integral V into dt is equals to E. This is for the statement number 1. This is for statement number 1 for time varying. Statement 1. While coming to the statement 2, very simple. I into R plus L into di by dt plus 1 by c integral v into dt minus c equal to 0. This is for statement number 2. That's all about the Kirchoff's voltage law. Today we will clearly learn about the Kirchoff's voltage law. What is the Kirchoff's voltage law? The law states that the sum of voltage drops across the elements present in the circuit is equal to sum of the voltage sources or applied voltages in the circuit. The algebraic sum of the voltage drops and the voltage sources around the circuit elements is equal to 0. We will see for both the cases, for DC voltage source and for AC voltage source, or we can time variant circuit. Okay. Thanks for watching. Thank you.